Alright, so this week we are going to continue with our this one will be third topic, skeletal system. And okay, and the objective for today, we are going to develop some understanding regarding structure of the skeleton, function of the skeleton, and also how the skeleton being made, being improvised. Okay, that this will be the aim for today, the objective for today. Alright, before we go to the actual topic, let's just do some recap on what we have learned through week 1, week 2, and week 3. The first one is the differences between quantitative versus qualitative analysis, where the quantitative analysis will be focusing more towards analysis with numbers, while qualitative analysis is an analysis that being conducted by using only description of outcome such as good, bad, whatsoever. And then we have anatomical reference position, which represent a position of standing up, facing forward, with your palm also facing forward. And with that anatomical reference position, we are having some of the directional term such as medial and lateral, which means towards the midline or away from the midline. We have superficial and deep, which is towards the skin or into the skin. And then we have superior and inferior, where superior is actually more towards the head, while away from the head, that is inferior. We have anterior and posterior, where more towards the front of the body, that will be anterior, and towards the back of the body, that will be posterior. And also we have three reference plane which divide our human body into three position. The first one is sagittal plane, which divide our body into left and right, or the plane where we view things or we view action from the side. The second one is frontal plane, the plane that divide our body anterior and posterior, or the plane where we view the action from the front or from the back. And finally, transverse plane, which divide our body into superior and inferior, up, top, and bottom, or the plane where we observe an action either from the top or from the bottom. Okay, ini adalah dia punya recap. Okay, other than that, we have axis. We have three axes. The one for sagittal is known as mediolateral. The one for frontal is known as antero-posterior, and the one for transverse is known as longitudinal. Okay, based on the axis and based on the plane, we have some of the movement, flexion, extension for the sagittal, okay, hyperextension, adduction, abduction for the frontal, and also rotation for the transverse. And finally, what we have learned last week is about spatial or spatial reference system, which we reference to Cartesian coordinate, the value of x and y, and how we define movement based on coordinate. This one is what we have learned through anatomical movement plane, which is the topic for last week. So this week, we are going to discuss about this thing. Skeletal system structure, okay, system structure. Before we start with skeletal system, here we have bones 206, and we have two type of skeletal system. Okay, these two type is distinct. Tadi saya dah nampak benda ni. Wait. Okay, let's see this one. Alright, the first group of skeletal system is known as axial skeleton, or the base. Ni asas dia, asal dia. It consists of the skull, the vertebra, the sternum, the ribs, and finally your sacrum and coccyx. Ni asal dia. And the thing that attach to the axial is known as appendicular. Okay, ni asal dia, tengah-tengah dia. and the thing or the skeleton that attached to the axial is known as appendicular, which is your hand and your legs. Okay, so tunjang dia ialah axial and dia punya cabang is appendicular. Remember these two. Okay, so axial benda yang tengah, asas. Benda yang bercantum dengan benda yang tengah, appendicular. So your torso, your head and torso is your axial, and your hand and the legs is appendicular. Okay, tu ingat tu. So again, axial consists of skull, consists of vertebra belakang ni. Depan dia we have sternum, we have ribs, and finally sacrum and your coccyx. Okay, while the appendicular consists of both your hand, we have sternoclavicular. Okay, kenapa nama dia sternoclavicular? Because it attached to the sternum. Tu datang sterno dia. Okay, it attached to the sternum, and this one is clavicle. So the composition of these two, penyambung ni, nama dia sternoclavicular. Okay, this bone is clavicle. This bone is sternum. So in order to fix sternum and clavicle, we have sternoclavicular. Okay, today. And then we have your apa ni? Your scapula here. We have your ni tulang apa? Ni anatomy dah belajar ni. Femur ke humerus? What is this bone name?
Humerus.
Humerus. Okay, always remember that. Femur kat kaki. Kalau lupa sangat macam nak beza femur kat kaki dah. Lagi satu kat tangan. Okay, we have partner dia humerus and femur. So this one is humerus. And then we have ni radius ulna ke tibia fibula?
Radius ulna.
Radius ulna. Okay, this is radius ulna. And then we have carpal, metacarpal, and finally phalanges. Jari, phalanges. Kaki, tangan sama, phalanges. Okay, so here we have apa ni? Yang besar ni. What is the name of this one? Tulang pinggul. Apakah nama tulang pinggul? Pel apa?
Pelvis.
Pelvis. Okay. Sama macam ni nampak sacroiliac. Kenapa nama dia sacroiliac? This is ilium. Okay ni. The whole segment is pelvic. Okay. This is what we call ilium. Atas ni kita ada iliac crest. Okay. So this one is sacrum. Since sacrum attached to the iliac, dapat nama tu sacroiliac. Okay, the attachment between sacrum and iliac. Okay. So apa lagi kita ada? Pubic ischium. Okay, ni tulang kaki yang paling besar. Apa nama dia? Kawan dia.
Femur.
Femur. Okay, this is femur. And underneath femur we have tibia and fibula. And towards the end, tadi kita ada carpal. Atas carpal. Bawah tarsal. Okay, we have tarsal, metatarsal, phalanges. This is the base. Okay, this is the base of skeleton. Kalau kita nak cerita satu-satu, dia banyak lah. Tentu ni dia semakin banyak. Okay, kita nak cerita satu-satu, you need to remember all those 206. But for the general term, which consists of axial and appendicular, that is just what you need to remember. Ambil yang asas je. Ni terlalu asas. Something like this. Okay. Alright, towards the back, we have vertebra, which we can divide this vertebra into berapa bahagian? 5. Okay, tadi bawah kita dah cerita sacrum, coccyx. And then we have lumbar, thoracic, and cervical. Okay, cervical is your neck. From the torso towards the end of the ribs, that is thoracic. And underneath thoracic or inferior to the thoracic is lumbar, underneath lumbar or inferior to lumbar is sacrum, and towards the end is coccyx. Ini adalah 5 bahagian spine. This is if we compare bones, this is the one of the bones, one set of the bones which is towards the posterior. Yang lain semua dekat anterior, depan. Ini belakang. Okay, towards the posterior. Alright. So our bones total is 26 joint and adjacent cartilages. Ni kita akan tengok minggu depan. The division of cartilages or joint, and function of our skeletal system is the first one to support soft tissue. Okay, what does it mean by soft tissue dekat sini? Apa sebenarnya soft tissue yang kita ada dekat dalam badan? How many soft tissue types do we have in our human body? Anatomy. Ada berapa banyak? Berapa banyak soft tissue yang kita ada dalam badan? Human soft tissue. Berapa banyak? Berapa jenis?
Cartilage saya ingat.
Cartilage, one of it lagi. Muscles, lagi. Oops, aku masuk.
Ligament.
Ligament, lagi.
Fascia.
Organ? Kita punya
Semua organ soft tissue
Ya ke?
Tendon.
Tendon, lagi. Tendon, ligament, itu semua soft tissue lah. Okay. First, support. That is the place where our soft tissue attach. Organ bukan. Okay, next one is protection. Okay, apa yang our skeletal system protect? Satu is organ lah. One of the thing is our organ. Lain pada tu apa dia? Apa lagi yang skeletal system protect? What are the other things being protected by our skeletal system?
Brain.
Brain. Okay, lagi?
Rib.
Rib tu skeletal. Kita nak tahu apa yang dia protect. Oops, sorry. Keluar sana pula. Kita nak tahu apa yang dia protect.
Lungs.
Lung. Organ. Lagi?
Liver.
Apa ni? Liver. Organ. Most of it is our organ. Okay, and then protection. Number 3. Movement. Lever system. Okay, when we talk about movement, when we talk about movement ni kan, in order for us to move, this is the step needed. Movement. We have sensory or efferent neuron. Send the sensor to our brain or central nervous system, which will make the computation and send the impulse back to our motor or efferent neuron, and from the motor it will activate our motor unit. Which eventually will contract our muscles and then make joint movement, and after we have joint movement, only we are going to have skeletal movement. Ini step dia. Okay. Sensor or what are the things that we see, we feel, it will be sent to our CNS, compute, and the outcome or the output will be delivered through the motor neuron or efferent neuron, which will activate our motor unit, engine dekat dalam muscle kita, which cause our muscle to contract. And when it contract, macam ni kan, kita ada bicep. Okay, let's say this is, sorry, kita kena ada nombor 1. Which will cause something like this. Macam ni. So this is our bicep. And when the bicep contract, it will cause our movement to be like this. So the size of the muscles change, which cause the hand to move upwards. And this movement occurs when the joint start to move first. And then only you're going to see skeletal movement. Ini cara untuk kita bergerak. And that is the reason why we cannot move without any movement at the joint. Itu untuk movement. Okay, and most of our movement is by using lever system. Class 1, class 2 or class 3 system. Yang ni kita dah bincang belum lever system ni? Do we have discussed this one or no?
Lever system pernah yang contract muscle, bila muscle contract dia akan angkat tulang liver semua.
Dah belum? Yang ada 3 jenis tu. Fulcrum kat tengah, fulcrum kat ujung.
Oh, itu
Belum
dekat kelas belum kot.
Okay, kalau belum maksudnya saya dengan budak-budak degree lah ni. We have something like this, we have something like this, or macam ni. And most of our human motion is actually ni. Okay, contoh macam ni lah bicep curl kan. So kita punya muscles kat sini attach to the forearm, and when contract occurs, this one is the source of force, this one is the resistance, and the elbow will serve as the fulcrum. Macam ni lah. Okay, for this 3 level, I just need you to remember one thing. It's not the placement of the fulcrum. It can be placed anywhere. I just need you to remember this. When we talk about lever, it consists of 3 different things. It need to consist of 3 different things. First, you need to have fulcrum ataupun dia punya axis of rotation. Second, you need to have sources of force. Third, you need to have resistance. That is the first thing. Second thing, the major properties which determine the fulcrum type is actually moment arm. Okay, moment arm ataupun jarak dia. Jarak apa? Okay, let's say we take one plane, put a fulcrum, and we put a force. So the distance between force application to the axis of rotation, this is known as force arm. Okay, force arm. And the distance between resistance with the point of rotation. Ni dia. This is known as resistance arm. Ni perkara kedua yang kamu kena tahu. Okay. Tu. Alright. Next. Okay. By knowing this, if we try to levitate, if we try to lift up object, okay, we try to use less force to lift up heavier object. Remember this, force arm need to be larger than resistance arm today. But if we focus on the range of motion, we try to have more range of motion. Force range of motion. Force arm will be less than resistance arm. Ni dia. Okay, dia. Pasal kalau kita ada benda macam ni. Ni example of bicep lah. Bicep, force kat tengah, This one is the fulcrum. This one is the resistance. Sama dengan bentuk tadi. Fulcrum, force, resistance. Okay, sama macam ni. If we have this one, meaning in order for us to lift up object, we need more amount of energy, because in the concept of lever, it follow one simple concept. It is known as equilibrium, where we try to make the system stable. Means that kalau kita namakan ni sebagai complex 1 and complex 2, at any given time of movement, complex 1 try to be equal with complex 2. Dengan kata lain, force arm always equal with resistance arm. And then only kita boleh dapat pergerakan yang stabil. Kalau force arm is larger than resistance, and resistance arm means we are going to get lift up. But if the force arm is lower than the resistance, and resistance arm, kita tak boleh angkat benda tu, because the resistance is too heavy. To concept. Okay, this is the concept of leverage, and most of human movement consists of leverage simply because of one simple things. Why human movement? Okay, why is it here? Movement lever system. Because of this thing. Our human movement have this fulcrum. Semua bahagian badan kita ada fulcrum, ataupun nama lain dia, nama kampung dia is joints. And then in order for us to move, macam yang saya note down dekat belakang ni, in order for us to move, we need to have this movement first. And that makes our motion to be leverage, ataupun to include lever system. Itu adalah function skeletal yang ke berapa ni? 3. Okay. And next one we have production of blood. Red bone marrow. Okay, blood cell production. Afterwards, we have storage, especially towards the storage of calcium and phosphor. Kita punya surface of the bone. Finally, storage of energy in terms of yellow marrow. Ini sikit je lah, storage of energy, because most of our energy being stored in terms of glycogen inside the liver and muscles. Itu function untuk skeletal system, the whole skeletal system. Okay. Ni contoh, dia bagi contoh lain. So we have the axial bone yang biru ni, or the white one, and the yellow one we have appendicular. Appendicular kita ada 126, axial bone kita ada 80, total will be 206. Okay, sampai sini dulu. Ada soalan? Any question? Ini mukadimah ni. This is the mukadimah. Okay. Alright, composition. Apa yang membuat tulang kita? Basis is 4 different component. Ini adalah asas dia. Calcium carbonate, calcium phosphate. Nampak? Calcium carbonate, calcium phosphate. This is the two things being explained here. Calcium and phosphorus. Calcium carbonate, calcium phosphate. And then we have collagen and water. All of these ingredient or building blocks serve a part of function for the bone. It serves as the properties of the bone. Kalau tak ada satu ni, kita akan hilang satu properties. Okay. So let's see the property. The first one is carbonate and phosphate. This is the most larger building block for the bone, because it gives the bone the shape and the stiffness, kekerasan. So if you lost calcium carbonate, if you lost calcium phosphate, tulang tak keras. Dia jadi macam jelly. Dia jadi macam something like that lah, macam jelly. Maksudnya dia tak ada bentuk satu yang keras. Dia rapuh. dia rapuh. You tolak, dia bengkok. Weh. Tapi dia tak patah. Pasal benda yang menyebabkan dia patah ni datang yang ketiga. Collagen. Okay. Dia lembik tapi dia tak break. Tu kalau kita hilang kalsium carbonate and calcium phosphate. The most easiest way for you to not remember lah, for you to see the effect of losing these two things is towards people with osteoporosis, where it lack in term of building up of the bone because it lacking of these two ingredient. Jadi dia tak boleh nak buat bone baru. Modeling cannot occurs, which make the bone rapuh. Kena ketih sikit, bertarai. Contohlah macam tu. Tak adalah sampai macam tu sangat. Okay, primary determinant for compressive strength. Compressive strength is something like this. Just put your hand on the table, straight like this, and try to push downwards. That is compressive. Meaning we try to compress things. Our bone is good at this. Okay, kita boleh compress dia takkan shattered. If you lost calcium carbonate and calcium phosphate, we compress the bone, it will be shattered. Dia pecah, berkecai. Ami, Akmal, soalan. Kau jangan kata tertekan. Ami?
Tertekan saya, tertekan.
Okay. So that is compressive strength. Okay, compressive. Maksudnya kita tekan dia macam ni. Kita push left and right, push inwards. That is compressive. By having calcium phosphate and carbonate, it gives stiffness, kekerasan to overcome this kind of pressure or force. Itu yang pertama. Okay, two major building blocks. The third one is collagen. Okay, collagen, 25 to 30% of bones dry weight add flexibility. Okay. Flexibility. Now we have some sort of flexibility. Kau jangan bayang pula flexibility macam kita buat. Flexibility tu, no, our bone cannot go up to that weight. But our bone is flexible, meaning that it able to absorb some sort of impact in terms of tensile. Okay, apa tu tensile loading? Let's see this one. Tension. Ada tak? Dia ni apa? Aduh, this is not tension. Ni. Kita tengok ni. This is tensile ataupun tension. Okay, meaning tadi kompresif, tekan. Now tarik. Means that our bone block, building block, it give the bone some tensile strength in order to give some flexibility to the bones. Jadi dia tak mudah patah. Contoh macam kita ada nampak tak benda ni. Can you see this? Kan? Okay, bayangkan ni kita punya bone. If we don't have tensile strength, kalau kita twist dia macam ni, ataupun ke atas, ataupun ke bawah, we give force in this or to that particular line, it will simply shatter. Tak ada contoh yang tu. Dia akan mudah patah. Okay, contoh kan, kau main bola, lepas tu kena tackle kat tulang kering. Tensile strength ni kalau tak ada, if we don't have this amount of collagen, patah dua, confirm. Setiap kali kena, confirm patah dua. Tu maksud dia, setiap kali kena, confirm patah dua. Kalau kita tak ada collagen, it gives some flexibility. Not total flexibility, but to a certain amount. There are flexibility. Compressive strength pula, contoh macam kita lompat, jatuh. If we don't have compressive strength, compressive force application, we jump, we land, our leg shattered. But because of the calcium phosphate, because of the calcium and the phosphorus, because of the collagen, we able to do some action without actually leave any marks toward our skeletal system. Tu function yang kedua. Okay, add flexibility, contribute to tensile loading, strength, ability to resist tension. Tension is being pulled. Okay, compressive being push. Okay, collagen is progressively lost and bone brittleness increases with aging. Means that through aging, we are going to lose collagen. We are going to lose the flexibility and we are going to start have skeletal chipping. Dia pecah-pecah dia. Macam mana nak cakap? Macam cat gerapuh. Pecah sikit-sikit. Tu brittle. Okay, and the fourth building block is water. So in the bone component itself, we have IE. Okay, we have IE, and this IE contribute to some of the bone strength and provide transportation for nutrient and waste. So we have nutrient coming in the bone, we have waste coming out from the bone because we have the process of building. Okay, building out of the bone. Nanti kita tengok terus dia, kita akan tengok. Okay, ni 4 bahagian dia. We have calcium phosphate, we have calcium carbonate, major building blocks, and afterwards we have collagen to add on the flexibility and also water. Okay. Building block tulang. Ada gambar tulang? Sekejap saya nak tunjuk building block tulang. Okay. Ni tanpa calcium phosphate atau calcium carbonate. So kita akan jadi lembik. Yang ini tanpa collagen. Dia akan senang hancur, rapuh. Okay. I want to show you these two things. First one. Saya cari gambar tulang. Okay. Tulang ni. This is the whole bones. Tadi, we have 4 different component. Okay. And please look at this one. Calcium carbonate, calcium phosphate, 60 to 70% of dry bone weight. And collagen, add on another 30 of dry bone weight. In other words, water dia tak cerita dry bone weight dah, dia cerita total bone weight. Meaning here is, calcium carbonate and calcium phosphate makes all of these things. Semua. And then, water, which located in the system itself. That is the reason why calcium phosphate, calcium carbonate plus collagen make out 100% of the dry bone weight. And water is towards 30% of total. Meaning dekat dalam ni bukan penuh dengan air, but it has. Okay, it has water. The bone itself retain some level of water. And inclusive of these 4 component make out the weight of the bone. Bukan dry weight lagi. Dry weight tak ada air. Total weight is when we add on air. Tu maksud dia. So nanti tengok, tadi dah penuh 100, air duduk kat mana? Air duduk dalam dia. Okay. Right. Next we have some protein dengan minerals ni bukanlah unsur-unsur yang banyak. It just has some amount of that. As for the protein, it contribute to flexibility, ability to deform and toughness. Protein dekat sini paling mudah kita nak faham. One is this one. Nampak ni? Epiphyseal plate. Kat sini. Although it is in the bone itself, but this one being made entirely from protein. Selain daripada tu, apa dia? Cartilages. Okay. All those cartilages which surrounding the bone. Tu protein. And it is actually part of the bone itself. Okay. Next one, we have some trace mineral that have vital structural and metabolic role. Magnesium, sodium, fluoride, in order to have the remodeling process. Tapi kalau orang tanya, what is the major building block of bones? 4. Calcium phosphate, calcium carbonate, collagen, water. And the trace, we have protein, we have some minerals. Okay, itu building block dia. Okay, so kalau kita tak ada calcium phosphate and calcium carbonate, our bone is able to do something like this. Okay, we able to do something like this. This one being made by dissolving all those calcium, phosphate and carbonate dengan masukkan dalam cuka. Kalau nak try benda ni, boleh try. Okay, but you need to have very pure vinegar and try by using chicken bones, dip and let it be. So dia akan hilang all those keras. Okay, bukan keras tu nampak begitu, tapi you able to bend that because we have dissolved all those calcium. Nak try boleh. Ni apa yang akan terjadi. And brittle Okay. Brittle when we have lost all collagen. Maksudnya, kamu twist, dia pecah. Tulang ayam tu kalau kamu twist, it takes some amount of force before it start shattering. Okay, but without collagen, dia dah tak ada flexibility tu. So you can simply twist and it will goes break. It will break. Ni maksud brittle. Jadi tulang kita semakin tua, dia akan semakin mudah dapat benda macam ni. Jatuh tangga, patah. Kecil-kecil dulu jatuh pokok, okey je, boleh bangun berlari. Okay, tapi bila dah semakin berumur, jatuh simple, jatuh satu mata tangga je, patah. Patah dua-dua kaki. Contohlah macam tu. Masa remaja, jadi Superman atau motor pun tak patah. Okay, that's the reason why. Because throughout aging, we are going to lose a lot of our collagen. So, we are going to lose the flexibility. Alright. Okay, sampai situ dulu. Soalan. Ada tak?
Tak ada lagi.
Enggak ada. Okay. Alright. Our bone, okay, regardless of placement, kisahlah dia dekat mana, okay, mana-mana bahagian pun tulang kita ni, it always consists of two type. Okay, it will consist of two type. The difference is just towards the ratio of porous. Okay, porous means cavity. We have lubang. So our bone consists of part with lubang and part which is solid. Okay, dia ada part yang solid, dia ada part yang berlubang-lubang, and it is concerning to all of the bone, bukan satu bahagian sahaja. And these two structure is known as cortical bone and trabecula. Okay, cortical bone and trabecula. Cortical bone and trabecula. Cortical bone compact, penuh, no holes, no sponge. Trabecula, spongy. Sometimes you are going to see the term cancellous. Okay, maksud dia high porosity. Cortical, low porosity. Trabecula, high porosity. Cortical, low. Trabecula, high. Porosity, lubang-lubang. Okay. So, throughout our bone, sekejap ada gambar lain ni. Saya nak tengok contoh gambar. Okay. Here. This bone and that bone is two different bone placement. Okay, two different bone placement. This one is more towards long bone, bone panjang. Contoh macam ni. Ni bone panjang, okay? We have humerus, we have radius ulna, we have femur, we have tibula, fibia tibula. Okay, 1, 2, 3, 4, 5, 6. Ni contoh long bone. Kenapa nama dia long bone? Dia panjang. Senang. Dia panjang. Dia yang paling panjang ada dekat dalam badan. Why vertebra is not being called as a long bone? Kenapa vertebra ni bukan long bone? Why? Why? This is not a long bone. If we compare all of the bone, this is the longest.
Sebab dia ada satu-satu bahagian tu jadi semua.
Betul. Sebab dia inclusive of multiple parts. Okay. So, kita punya vertebra ni bone apa?
Irregular bone.
Irregular bone. Yes, because the shape is irregular. Kejap memanjang, kejap membulat. Okay, so we have long bone. We have short bone, our tarsal, metatarsal, phalanges. We have flat bone, macam ni. Skull. Okay, we have flat bone. We have scapula, flat bone. We have ilium, pelvic ni, flat bone. And then we have irregular bone, vertebra. Apa lagi yang bentuk irregular? Sacrum, coccyx. Apa lagi yang bentuk irregular? Sternum kita ni bone apa? Sternum.
Flat.
Flat. Okay, pasal apa? Pasal dia rata. Kan senang je. Apa ni? The division of bone is simple. Panjang, long bone. Pendek, short bone. Bentuk tak tentu arah, irregular bone. All those flat is flat bone. Okay. Although the shape is different. Macam ni kan, kita tengok long bone panjang. Short bone macam long bone, panjang-panjang. Short bone macam long bone, panjang-panjang. However, for irregular, dengan apa ni, dengan flat bone, the shape memang lain. Dia dah bentuk panjang-panjang macam ni. However, this one, okay, sebelah kiri ni, this is representing short and long bone. And this one, towards the right hand side, representing flat and irregular. Kita tengok komposisi dia. Yang ini tak clear. Kejap lagi kita tengok yang clear. Kita tengok yang ni clear. We can see towards the middle, we have all those trabecular bone or spongy bone, and towards the deep, okay, deep side of the skeleton. Towards the superficial, we have cortical bone or less spongy bone. Jadi benda tu memang ada dekat dua-dua bahagian. You're going to see apa ni? You're going to see those two division of bone. Untuk long and short, kalau macam ni kan, kita boleh nampak in the middle, we have trabecular. Towards the surface, we have cortical. And another part is this one. Ni. This one. Towards the head of the bone, we have more trabecular. But towards the middle, we have more cortical. Ini untuk long and short. Okay, this one is for long and short bone. Towards the middle, it will become more or less porous. Towards the head or towards the end, both superior and inferior end, we have more trabecular ataupun spongy bone. Tapi untuk bahagian flat and irregular, dia punya placement lebih kurang macam ni. We have towards the middle, towards the deep side, towards the middle lah. Okay, towards the outer layer of the bone, we have cortical. Towards the inner or the middle part of the bone, we have trabecular. Means all of this skeletal, inclusive of those two, trabecular and cortical. Kenapa mesti ada dua-dua? Okay, now let's see the reason why. Cortical bone, since it is compact, low porous, found in most of the shaft, okay, this type of bone is more susceptible or more prone or able to withstand more compressive strength. Dia kuat dekat compressive tapi dia tak kuat dekat tension. Means cortical bone, if you put some tension, means you pull or you twist, it will easily shatter. And to avoid that, to overcome that problem, we have trabecular. Okay, we have trabecular bone. So trabecular bone able to give the flexibility because it has some porosity. Means it able to slightly move. Tapi bila dia trabecular, if we give too much compressive strength, dia shattered because it is not able to withstand more compressive force. Jadi bila kita ada dua-dua in one piece of bone, it give you both effect. It can withstand strength, it can withstand tension at the same time. Itu maksud dia. Why that is the reason, bukan maksud, makna. Sebab, okay, that is the sebab why we have both trabecular and cortical bone at each of the skeletal system. Okay. So next question will always be why being shaped or why the placement is different. It because of the function. If the function of that part is to withstand strength, such as our leg, okay, our tibia, fibula, femur, where we need to have load bearing. So we are going to have more cortical. But if the place is more towards force absorbing, we are going to have more trabecular. Example, kepala. Banyak benda tergantung dekat situ. Example, pubic. Kita selalu terduduk. Example, your tarsal metatarsal phalanges, where we need to absorb most of the land. At that place, trabecular is going to dominate. Dia macam tu. Okay, dia macam tu. It depends. Our bone modeling depends on the function. If the function change, the modeling will change. Okay, tu yang the reason why. Okay, and then here we have epiphyseal plate. Tengok ni, epiphyseal plate. Okay, epiphyseal plate. So this epiphyseal plate is the place where elongated of your of your bone occurs. Dekat situlah proses memanjang terjadi. And proses memanjang, there are duration and they always stop when you reach 18. Lebih tak ada dah. So kalau 18 masih pendek, bertambah. That is that. You are not going to be tinggi anymore. Situ je lah. Okay, itu process of elongated ataupun vertical displacement. However, for the size of the bone, okay, the circumference of the bone will keep on increase according to load bearing, and it won't stop. Sampailah satu tahap where your mineral composition inside the body is lacking and you are unable to supply the mineral. And when that happen, the process of modeling is not going to occur anymore. Maksudnya sampai satu tahap umur yang mana kita dah tak boleh nak consume carbonate, calcium, both carbonate and phosphorus. We cannot supply ample. So the growth in term of width is not going to be there anymore. Growth in term of length occurs up until 18. Growth in term of width, it does not stop unless we are unable to supply the building block, and then it going to stop. Jadi pembesaran tulang dua hala. One in term of long, okay, memanjang. Two in term of width, melebar. So long occurs at the epiphyseal plate. Okay, epiphyseal ni dia akan terjadi dekat tanah bawah. So it will keep increasing the height. As for the width, it will occur throughout the layers of the bone itself. Dekat bahagian cortical luar tu, dia akan keep on increasing and keep increasing the size in term of width sampai satu tahap where we are not able to supply enough building block. Itu adalah pembesaran dia. Okay, this is bone structure. Okay, ni bone structure lagi lah. Okay, we have part of long bone. This one is femur, tibia, fibula, humerus, radius ulna. This is the shape of it. Okay, so kita ada distal epiphysis. Distal is towards out of the head. Yang atas ni proximal epiphyseal. Maksudnya proximal epiphyseal ni, it is nearing the abdomen. Okay, ingat kita punya tajuk dulu, proximal distal. Distal epiphyseal menjauhi kita punya abdomen. Tapi dia bahagian dia sama. Dia ada metaphysis, diaphysis, again metaphysis for the proximal and proximal epiphysis. Bawah dia distal epiphysis. So why epiphysis? Because this is the place where you have your epiphyseal. Okay, so apa beza dia? Diaphysis ni, this is cortical. Metaphysis sampailah proximal, metaphysis sampailah distal, this is trabecular. Dia punya composition berbeza. Okay, itu dia. Okay, diaphysis shaft consists of central medullary cavity. Metaphysis is the wide portion of a long bone between the epiphyseal and the narrow diaphysis. This is the region of growth. Inilah yang akan membesar. Membesar dia bagaimana? This is the longitudinal, ke atas ke bawah. So meaning this spongy area will keep on increasing in term of height. Okay, sampai sini dulu. Bone structure sampai sini. Any question?
Tak ada, sir.
Okay, ni yang tadilah. Alright, so kalau yang macam ni, okay, macam kita punya kepala ni kan, so we get increment of size. Okay, that occurs dua hala lah. Kalau dekat bahagian femur, it occurs at the epiphyseal. But in our head, it occurs both in the trabecular and cortical. Cortical keep increasing the hardness, trabecular keep increasing the size. Yang ini, nampak tak? Can you see this curve? Sampai sini kan dia turun. Can you see this? Semua ni trabecular, tapi dekat sini kita boleh nampak macam ada satu line putih. Just follow my red dot. Okay, sampai sini dia turun. Can you see this one? Ni epiphyseal plate dia. Okay, this is epiphyseal plate. So pembesaran occurs here di bawah, which resulting tulang tu naik ke atas. That is how later on kita akan tengok. Okay, with the help of osteoblast and osteoclast. Okay. Alright, can we continue?
Kan.
Okay, right. Next one, benda yang sama je ni. Cortical bone, trabecular bone. Okay, cortical bone, trabecular bone. Cortical, less porous, kurang lubang. Why it is kurang lubang? Because cortical bone is much more stiffer, keras, and it able to withstand greater stress. Dia ada dua term yang dia pakai. Satu stress, satu compressive, same thing. Stress. Okay, this is stress. When we push, stress. When we pull, tension. When we push, stress ataupun compressive. When we pull, tension. Okay, tu dua beza. Okay. Can withstand greater stress but less strain. Strain is pulling. Tension. Ini yang kedua tadi. Okay, more strain. Okay, more strain for trabecular. Means trabecular is able to withstand strain. We pull. And when we pull, sometimes we rotate, torque. Jadi yang menghalang tulang kita daripada patah from pulling action and from some level of torque is trabecular because it consists of porous area. Porous area able to move slightly a bit. But if it is tight packed together, if we rotate it or if we pull, dia akan brittle, dia akan hancur. Okay, itu trabecular dengan cortical lah. And the similarities between those two, both cortical and trabecular bone are anisotropic, different according to direction of measurement. Okay, bone is anisotropic, it has different strength and stiffness depending on the direction of the load. Maksud anisotropic ni kan, if we push bones, kita ambil gambar ni. Okay. Sekejap, saya ambil gambar satu je besar. Nampak kecil. Sekejap try to find. Boleh lah. Okay. Kita letak compressive strength. Okay, compressive. Kita tekan. If we put force dekat otak ni, dekat otak, dekat skull ni, we push the skull together macam ni. Thus, compare tu, kalau kita pegang kita punya humerus ni kan, and then we clamp. Satu, yang mana yang pecah dulu? Kepala kita ke? Atau kita punya humerus? Kita clamp, push it forward, or we put a clamp dekat kita punya humerus and we tighten. If we compare these two, which will break first?
Kepala.
Common sense. Kepala. Okay. Itu yang pertama. Yang kedua. Still we take the humerus, but now instead of we clamp the humerus from left and right, we put force at the top and at the bottom, and we compress. Comparing the first situation and the second situation for humerus only, which direction of force will break it easier, from left and right or from top and bottom? Yang mana yang akan
Top and bottom.
top and bottom? Okay, if we compare that one, from left and right will break it much faster compared to top and bottom. Okay, so direction of force. That is what the meaning of anisotropic. Means it has different strength. Although strength humerus ni, kita boleh cakap dia tulang panjang. So it has a lot of cortical area. It is quite good at compressive strength. However, if the direction of strength is different, it gives different outcome. So if we give compressive strength from left and right, it will break this one much faster compared to if we give from top to bottom, because this bone being made to withstand compressive strength from top and bottom. Kalau tak percaya, senang letak tangan kita tegak-tegak macam tu, suruh orang pijak kamu punya femur, dia patah. Dia akan patah. That is the meaning of anisotropic. Meaning the bone stiffness is depend on the direction of the load. And which direction? It depends on the function. Contoh, kita ambil Muay Thai kick 3. Okay, tadi kita kata long bone is good at compressive and not good when the direction is poor. Same goes as your tibia and fibula, meaning it good at compressive from top and bottom. But this fella will show you differently. See. Okay. Kenapa dia tak jadi macam ni? Soalan ni. Belum pasal dia tunjuk gambar-gambar mengarut lah ni. Okay, so the question will always be, why that fella leak does not occur like this? Sedangkan that example show tension, or it show compressive strength from not so good direction. Tulang panjang, compressive dia top and bottom, but this one is from side. Okay, that is the meaning of anisotropic. it has different strength, and bone function determines structure. Okay, the sole reason why that fella able to kick wood, break tree, and also steel pole is because of, kita cari because of tu. Okay, we skip this one first. It's because of this thing. Osteoblast versus osteoclast, and the process is known as this one, remodeling. Okay, because bone respond to stress, kicking all those things inflict a great amount of force towards that particular bone, and that is the stress. And based on Wolff law, indicate that bone strength increases and decreases as the functional force on the bone increase and decrease. Okay, so how they increase the strength of the bone is by remodeling. Okay, bone continue to grow and remodel, meaning it keep on change. The shape of the bone keep on changing. Bukanlah long bone jadi short bone, no, but the width keep on changing based on function. Okay, size and shape to accommodate the changing force applied to the skeleton. Okay, if the strain is higher than modeling threshold, the bone modeling will occur. Okay, bone modeling dia macam ni. Kita tengok ni balik. Kita tengok gambar ni. Okay, this is bone. Ngam-ngam. Ngam-ngam sword. Osteoclast, dia akan pecahkan. Osteoblast, dia akan buat. Meaning you are going to get a new set of bone skin. Makin baru, makin baru, makin baru. If this amount of wall cannot withstand the new force, macam tadi kan, sepak pokok, meaning that your brain will send signal to that particular bone, it need to be remodeled. Kita ada modeling and remodel. Modeling and remodel. If the bone being made similar as this one, okay, sama je, and then a new set amount of stress being inflicted from this area, it will send the signal, see that we need a new model. So osteoblast will keep on pounding this area and make a new set of surface. Katalah sebelum ni dia hanya perlu tahan 10 Newton, now dia perlu tahan 20 Newton, means dia kena ada 2 lapis. So osteoblast will make 2 set of surface in order to overcome, in order to face the new force. Itu maksud modeling. Remodeling is when this area, tadi 20 Newton, dia cakap okay, now we don't need 20 Newton, we just need 10 Newton. So dia akan remodel balik kepada bentuk asal. Itu maksud modeling, remodeling. Okay, itu yang asas dulu. So we go back. Nanti sampai situ kita tengok dia punya video, modeling and remodeling.
So boleh tengok balik slide yang bone growth and remodeling.
Belum lagi, sekejap lagi lah. Nanti kita sampai situ. Saya pun nak tunjuk kenapa kita boleh sepak batu.
Okay.
Because of osteoblast and osteoclast make two works. Modeling, remodeling. Okay, modeling and remodeling. Soalan ni bermula daripada situ tadi, daripada sini. What is anisotropic? Kenapa function dia berubah? Tadi kita dah cakap for long bones like this, the force, the threshold to withstand force is actually from top to bottom. But some cases, it is better from medial and lateral. Macam tadilah, orang tu sepak ke tulang kering. So that force come from this way. It is not from top and bottom, tapi sideways. Meaning, there will be new modeling occurs in order to enhance dia punya cortical dekat bahagian kiri dan kanan in order to withstand force yang macam ni, not macam ni. Okay, this is compressive force. This is also compressive force. But our bone is good for this kind of compressive and not this kind. With training, we can increase this kind of force, medial, lateral. That is the meaning of anisotropic. Itu maksud anisotropic. Okay, so tulang kita, semua bahagian, it is anisotropic. It has different strength and stiffness depending on the direction of the force. Okay, kalau benda tu tak cukup strength, we make new model so that it can withstand the strength. Okay, so how does the structure of bone affect? Bone is strongest in resisting compression, and weakest in resisting shear. Shear ni macam ni. Ni kan? Tu pusing. Meaning that one force acted like this, another force acted like that. So it cause rotational. It cause rotational ataupun it cause torque. Tu pusing. Pegang tangan orang tu kan. Pegang dia punya apa ni? Humerus tu. Satu dekat siku, satu dekat shoulder. Pusing macam pulas kain. Nah tu shear. Okay, that is shear. Tension, we pull. And compression, we push. Okay, soalan yang tadi pula, from where we push? Push macam ni ke? Ataupun push macam ni? Dua-dua compression. Okay, dua-dua compression. Based on this, it said that it's good at this. But why somebody able to kick that particular tree, somebody when they perform that kind of action, tulang keting dia kaput. Contoh main bola, kena tackle tulang keting, oh sakit weh. Ataupun you main martial art, tulang keting bertemu tulang keting. It will cost you many days of walking. Tapi with a proper training, kita boleh bagi tulang keting dekat orang. Because we have increased the tensile strength of the cortical area on that particular skeleton. So benda tu boleh terjadi. Okay, ni contoh. Okay, this is compressive. This is tension. This is shear force. Okay, this is shear force. This is shear force. Okay, dia tiga, empat benda ni. So we are good at compressive, our bone. We are good at tension. We are not good at compressive. This is some example of compressive. When your leg try to move that way to the left, your body want this leg to move that way to the right. So kita ada dua force acted upon the system from two different cause. It will cause a snap towards your long bone. Piak kat situ. Kaput. Okay. Alright. And this one, ni dah. This is the type of bone. Okay, the shape of the bone. We have long. We have short. We have flat. We have irregular. 4 jenis. Okay, this is what this is being answered by your friend. So beza dia, the shape itself. Yang kedua, the composition. Macam yang kita bincang tadi. The placement of those trabecular and cortical. It difference. Okay, it difference. Long bone consists of long shaft and bulbous end. Ujung dia ada kepala. Okay, mostly long bone is appendicular. Short bone sama macam long bone. Okay, sama macam long bone, quite similar in term of shape, except it is shorter. Okay, flat bone, you have an extensive area of bones. Kawasan lapang. Ada di kawasan yang rata. And irregular bone, tak payah fikir banyak. Irregular bone, it has irregular shape. Means that we cannot describe it as long because it is short, but when we try to make it as a short bone, it has protruding area. So, it is not long, it is not short, it will be irregular. Okay, and the shape of irregular bone follow function. Kalau function dia untuk mempertahankan spinal cord, the shape will be vertebral lah macam tu. Dia ada kawasan. Okay, dia ada certain kawasan. Okay, itu adalah irregular bone. Ni paling senang ni. Bentuk untuk irregular dekat dalam badan kat mana? Mandible. Contoh mandible kita punya ni. Okay, kita punya ni. Ni irregular ke? Short ke? Long ke? Flat? Apa ni? Rahang. Tak ada lah ni kan? Kita punya rahang. Tu. Ni bone apa? Come on guys. Bone apa ni? Rahang. What kind of bone is this one? Ada ni. Do you see rahang?
Regular.
Irregular. Yeah,
Regular.
regular. Okay, tengok dia punya definition. Long bone consists of long shaft. Ada long shaft tak? Do you see any long shaft? Shaft ni maksud macam ni, bahagian tegak. This is shaft. Diaphysis tu, that is shaft. Do you see long shaft here? No. Bukan long bone. Short bone, irregular in shape, small, chunky, and roughly cubical. Maksud irregular ni bentuk dia lebih kepada kepetakan. Contoh macam ni lah, tarsal, metatarsal, carpal, metacarpal. Dia kepetakan. Can you see kepetakan?
No.
Sekejap boleh kita keluarkan. Mandible skeletal. Can we see some kepetakan here? Enggak ada. Okay, ada yang baru masuk. Siapa tu? Tak ada. Okay, tak ada kepetakan. So, not short. Flat bone. Skeletal structure, they are largely flat in shape, serve as extensive flat area for muscle attachment. Can we see this as flat bone? Flat tak? Flat. Okay, this is flat bone. So, dekat mana muscle attachment dia? Where is the muscle attachment for this bone? Muscles. Kat situ. Dekat bahagian sisi ataupun towards the lateral side of the flat bone. Means when you see that the place is an attachment for muscles, most probably it will be flat. It will be flat. Okay, tu mandible adalah flat bone kat sini. Okay. So before we go to bone growth, please recall back what we have learned earlier regarding wolf law. The bone is going to increase in terms of strength based on the function. Okay, so bone growth and development, as what we have discussed earlier, it can happen in two ways. One is longitudinal, memanjang. Another one is circumferential, width, melebar. Okay, and longitudinal growth most of the time occurs at the epiphyseal plate and it stops at 18 years of age. Okay, it stops. Some of you can be seen up to 25, meaning after 25 tak akan ada lagi dah. Dah habis dah in term of longitudinal, but not towards circumferential. Circumferential ni dia punya width, dia punya lebar. Okay, so for the circumferential growth, diameter increases throughout the lifespan and most rapid growth before adulthood. This one referring to wolf law. Okay, and bone growth and development occurs, ni epiphyseal lah. Okay, this occurs due to osteoblast and osteoclast. Okay, these two fella works with one another. Untuk orang yang osteoporosis, this fella still working, this fella stop working. Meaning that breakout still occurs but not making it back. Osteoblast B buat balik. Osteoclast C hancurkan. Okay, osteoblast buat balik. Kawan dia osteoclast hancurkan. Normal, we are going to see osteoclast and osteoblast works with one another. Ini kalau kita buat remodel. Okay, kalau kita buat remodel, dia pecah, dia buat. Kalau kita buat modeling, dia buat. Maybe dia pecah, dia akan tetap buat kerja. Osteoporosis, dia tak buat kerja. Dia masih bekerja. Okay, so osteoblast and osteoclast works by this one. Osteoblast buat bone forming cell synthesize and secrete unmineralized ground substance. This unmineralized ground substance start from osteoclast. Okay, so osteoclast pula cell that enzymatically break down bone tissue. So the cortical plate will be break down. They will release calcium, magnesium, and other minerals to the blood. Magnesium, calcium, other minerals is unmineralized ground substance. Okay, specialized bone cell that reabsorb bone tissue. Osteoblast build new tissue. Osteoclast reabsorb. Okay, jadi kerja dia kita boleh panggil dalam dua proses. Ada tak kat sini? This is the two process. One is known as remodeling, another one is known as modeling. Okay, now let's see some example first. Okay, ada satu ada video. Okay, let's see this one. Ni nucleus, maksudnya ni sel.
The skeleton changes across the human lifespan. This is characterized predominantly by bone formation and growth throughout childhood, followed by a gradual loss of bone density that begins in early adulthood that can accelerate significantly in older adults. The density...
Okay, tengok surface dia. Kamu tengok surface dia. Keras, porous, cell. Tiga benda
of bone is modulated by a group of cells including osteoclasts, which are multinucleated cells that resorb bone, and osteoblasts, which
Okay, again. Porous, hard shell, cell. So the red one here is osteoclast. Hancur, hancur, hancur. So apa yang dihancurkan is the mineral. Jadi mineral ni apa? Calcium carbonate, calcium phosphate. And this one is the surface of the bone, meaning cortical part. Okay, this is the cortical part.
Bone is modulated by a group of cells including osteoclasts, which are multinucleated cells that resorb bone, and osteoblasts, which refill the resorption cavities created by osteoclasts. Osteoclasts anchor themselves to the surface of bone. This creates a microenvironment underneath the cell, which is referred to as the sealed zone. Within this zone, the osteoclasts create an acidic environment that dissolves the bone's mineral content. Once the mineral content of the bone has been dissolved, enzymes released from osteoclasts remove the remaining collagenous bone matrix to complete the process of resorption. Following resorption, osteoblasts move into the resorption space and start to produce and deposit organic matrix called osteoid. Osteoid, a substance made predominantly of collagen, forms a scaffold in which minerals including calcium and phosphate begin to crystallize. Some active osteoblasts become trapped within the matrix they secrete and thereby become osteocytes. Other osteoblasts will undergo apoptosis or will revert back to lining cells which cover the surface of bone. This cycle of bone resorption and formation is referred to as remodeling. There is also a process where bone formation by osteoblasts occur without prior bone resorption by osteoclasts.
Okay. Proses yang pertama tadi, this is what we know as remodel. Means osteoclast break down certain part, osteoblast create, okay, build up. Next process is modeling sahaja. Means osteoclast tak ada kat sini.
There is also a process where bone formation by osteoblasts occur without prior bone resorption by osteoclasts. This results in an increase in bone mass and is referred to as bone modeling. Bone modeling promotes the growth of bones and is important for maintaining bone strength. Remodeling also plays an important role during bone growth by optimizing the growing structure. After the age of 30, most people experience a gradual loss in bone mass due to a relative decrease in the activity of osteoblasts compared with osteoclasts. However, there are many factors that impact the process of bone remodeling and influence the degree of bone loss we experience as we age. For example, medications such as glucocorticoids, which can promote osteoclast.
Okay. Boleh faham? Do you get the idea?
So maknanya apa tadi nama dia?
Osteoclast.
Yang osteoblast tu dia melibatkan modeling modeling melibatkan osteoblast saja.
Ya. Okay. Nak faham lagi satu dia macam ni. Katalah this is the house that you live now. Okay. Jadi rumah ni ada bilik air, bilik 1, bilik 2, bilik 3, hall. Okay, this is the structure. Lepas tu, bilik air ni rosak. Selalu sangat rosak. Resulting, your father scrap this room out and then build out a new bilik air. This is remodeling. Ataupun dia build out new bilik air bukan kat sini dah. Wek. Sip bocor je. Kita buat satu kat sini. Bilik air. This is remodeling. So the process of getting out of this being done by osteoclast, and the process of make a new one here is made by osteoblast. Okay, dia dissolve ataupun the process known as resorption. Okay. Satu model lagi. Bilik air, bilik 1, bilik 2, bilik 3. Okay. Modeling pula, there are no breaking out. Mungkin kita dah ada ramai orang kan. We need to have bilik air 2. We are going to have bilik 4. New compartment being made entirely by osteoblast. New modeling. This remodeling, meaning that it still serve the same structure. Masih lagi ada bilik 1, 2, 3, bilik air 1 and hall. But maybe it being made at the same place or it being changed to a new one. That is remodeling. Remodel balik. Kalau kita kata modeling, meaning that the function of the skeletal system may change. Function bukanlah function short bone jadi long bone, no. But the weight bearing change daripada dulu weight bearing sikit, now weight bearing banyak. So we need to add on a new one. That is modeling. Okay. Itu beza remodel and model. Okay, satu contoh tadi ada satu gambar saya tunjuk. Ni contoh remodeling. Okay, this is remodeling where we can see that osteoclast start to dissolve all those bone lining cell, meaning that at the surface of the cell we had bone lining, we had calcium phosphate. All of that will be dissolved by osteoclast by the process of resorption. Okay, and then by resorption, there will secreted all those minerals, and these minerals with a combination of osteoblast, they will undergo a reversal process, and a new bone lining cell will be formed by osteoblast, and this bone lining cell will undergo mineralization process, and it will become a new bone. Dia berkawanan. If for modeling, ni tak ada. Okay, they start with osteoblast, they go for mineralization, meaning that bone remodel, it will remain the same function. Maybe the change is towards age. Jadi nak meninggi kan, dia pecah kat sini, dia buat kat atas. Dia pecah kat sini, dia buat kat atas. Itu remodeling. Kalau bone modeling, okay, macam kaki tadi, we need to have a good tensile strength at the medial side of the bone. So we are going to make a new bone layer at the medial side. Itu modeling. Okay. Ada lagi satu gambar tadi yang lagi senang. Ni dia. Okay. Ni ada dua. Bone growth, bone remodel. Okay. Bone growth is modeling. So we can see a new bone being made at the superior part of the epiphyseal, at the inferior part of the epiphyseal, new bone. Okay, which resulting this bone to have longitudinal growth. Tapi untuk remodel, what they make is, ni bentuk asal. Okay, this is bentuk asal. They change the bone shape. Nak membesar kan? So they are going to resorb. Okay, resorb some area and reformation of a new area. Itu beza remodeling and modeling. Okay, remodeling means make it back. Modeling means add on. Okay, remodel, make it back. The same structure, the same function, maybe different size. Okay, kalau tadi building block dia ada 10, remodel still 10. Tapi arrangement berbeza. Modeling, tadi ada 10, now ada 12. Tu model. Okay, ataupun macam ni lah. Kita ambil blok Lego 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, kalau remodel means we are going to change the shape of this 10. Maybe dia akan jadi 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Still 10, but different arrangement. This is remodel. Means osteoblast is going to knock down these two. Osteoclast is going to build up these two. Modeling 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It will become 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. This is modeling. Means here, osteoblast do the work without any help from osteoclast. Remodel, osteoblast, osteoclast. That is the difference between those two. Okay, sini sampai sini. Boleh faham?
Faham.
Okay. Tu beza dia. Okay, and those two is because of ni dia, bone growth and remodeling. Bone continue to grow and remodel themselves throughout life, changing size and shape to accommodate the changing force applied. Modeling pula, Okay, this is example being done. Children, femur become longer. Mechanical loading causes strain. If strain is lower than remodeling threshold, the bone remodel occurs at bone that is close to marrow. Maksudnya pembentukan baru, modeling baru tu akan sentiasa ada. Meaning a new cortical area will be made. Tapi dia dekat dengan dalam. Unless there are more strain dekat bahagian luar. Okay, bone modeling pula, if strain is higher than modeling threshold, meaning that if the force that a certain bone can have, okay, is larger than the limit, modeling will occur. Limit tulang tu boleh tahan 10 Newton. Sekarang 12 Newton. So we are lacking 2 Newton. So new model will be add on to accommodate those 2 Newton. Ini cerita in term of force lah. Kalau bone remodel, tak ada. It serve the same purpose. Except change in term of shape and size. Tu modeling and remodeling. If the threshold is not yet there, so modeling does not occur. If the force above the threshold of the bone strength, and then modeling will occur. Remodeling will always occur in order to accommodate change in term of our physics. Okay, so bone mineral density generally parallel to body weight. Ni dia lah. Okay, bone mineral density. So the density will increase accordingly to our body weight. If our body weight tu dah terlalu besar, maksudnya threshold dia dah surpass the threshold of the bone. Modeling will occur. Okay, a new model will occur. So at one point, modeling tak occur, remodeling tak occur, osteoporosis. Osteoclast still buat kerja. Resorption still happen. But no building up again to osteoporosis. Okay, and then we have bone hypertrophy, the increment of bone density. Increase in bone density and mass due to predominance of osteoblast. Predominant of osteoblast modeling. So bone hypertrophy is modeling action. When we put a lot of force, a lot of strain towards our bone, up until the point where the threshold of load is overcome, and then modeling occurs. Dapatlah kita hypertrophy, tulang kita menjadi semakin berat, semakin besar. Okay, that is hypertrophy. And also we are going to get bone atrophy, a decrease in bone mass resulting from a predominance of osteoclast accomplished via remodel. Osteoclast buat kerja 10, osteoblast buat kerja 8. So we are going to get lacking in terms of new bones. Ini maksud atrophy. So decreases in bone calcium, bone weight, seen in bedridden patient, sedentary elderly and astronaut. Dengan kata lain, if you don't put weight towards your bone, it will go atrophy. Jadi kalau main gym kan, buat badan lupa buat kaki kena atrophy. Kaki kecil badan besar, boleh jadi. Alright, and then we have osteoporosis, disorder involving decrease of bone mass and strength with pain and one or more fracture. Okay, jadi osteoporosis ni due to hormonal changes. Most of probably will be post-menopause. Bila post-menopause, kita punya hormone secretion will be out of order. So osteoclast function kaput. Okay, inactive, lower dietary calcium, like we have discussed earlier, when we cannot supply the building block. We cannot supply the enough calcium carbonate, enough calcium phosphate, so no new building block. Osteoblast ada, tak boleh buat kerja. Okay, kalau dia kena autoimmune, osteoblast tak ada, osteoclast buat kerja. Sama juga ending dia. Okay, so this is the example of osteoporosis. We can see that the porous or the cavity size become larger, which make this fella prone to fracture. Okay, ataupun make the bone become much brittle. Ni osteoporosis. Okay, so we have two type of osteoporosis. Type 1, post-menopause. Type 2, age-associated. Type 1, caused by hormonal changes. Type 2, caused by lacking of calcium. Ni dua sebab. Ending dia sama. You are going to get increment in terms of porosity of your bone. Okay, this is some of the symptom. Yalah. Okay, other than that, female athlete triad. Pernah tak terjumpa Ni bukan penyakit tapi dia macam macam mana nak cakap macam mana saya nak sampaikan female athlete triad ni? This is not penyakit but it caused by your belief. For example, you play a sport and when you play a sport you try to become certain type of body. You try to be that kind of body. Tak nak apa ni? Endo, nak mesu contohlah. And by changing a lot of things, especially towards your diet, first you're going to get osteo and then you're going to get eating disorder. Ni akan dapat amenorrhea and then also anorexia. Selalunya bila female athlete triad. Okay, amenorrhea, cessation of menses. Why menses cease to present, berhenti, especially towards female athlete, is because of your lifestyle. It's because of the hormonal secretion pattern change. It's because you are lacking of estrogen. Jadi bila benda tu terjadi, you're going to stop menses. And this is quite similar as post-menopause. So kamu akan dapat juga osteoporosis because the enzyme needed in order for osteoblast and osteoclast to work on is lacking. Dia ni macam penyakit and it caused by your belief when you play sport, especially to female. Okay, tu kadang-kadang bila female aktif sangat sport, you're going to notice that menses tak cantik. Dulu every month, now maybe 6 months once you have your menses. Okay, if you happen to be in this particular place, please seek medical specialist and discuss with them about hormonal therapy. This one can be cured lah, but it takes time. Okay, ni contoh dia treatment ni. Hormone replacement, estrogen deficiency. This is a cause of cessation of menses. Okay, and then we can increase dietary calcium, especially to type 2 osteoporosis, and also lifestyle factor affect bone mineralization. Especially if you are sedentary, hypertrophy jarang-jarang berlaku, but hypertrophy always occurs. So we need to change in order to avoid osteoporosis. Right? And then some pharmacological agent may stimulate bone formation, low dose of growth factor, engaging in regular. Again lah, benda yang sama je ni. So kita teruskan. Okay. This one talks about common injury towards bone, towards your skeletal. And the most common is fracture, patah. Okay. And fracture can be classified either a simple fracture ataupun compound fracture. Simple fracture means a type of fracture. Compound fracture means combination. Okay. So simple fracture occurs when the bone end remain within the surrounding soft tissue. Soft tissue. Compound means protrude. Simple fracture usually bone masih lagi dekat dalam, kulit tak koyak. Compound keluar. Tulang ulnar radius keluar. Pacak dia tu. Itu compound lah. So, kecederaan dia teruk. Okay. And this kecederaan always caused by shear or tension. Okay. Stress ataupun compress, if the compress being given to the bone in not favorable direction, dia boleh dapat fracture. Okay. When the loading rate is rapid, fracture is called comminuted containing multiple. Ni maksudnya dia brittle, dia pecah. Okay, this is maksudnya dia pecah. Sekejap Okay, comminuted. And then avulsion, a fracture caused by tensile loading in which a tendon or ligament pull a small chip. Okay. Tulang kopak kerana tension of tendon. Maksudnya macam ni. Okay. Ni green stick, not a complete fracture. Kalau transverse fracture, complete. Okay. Fissure, selalunya dia longitudinal. Okay. Green stick, horizontal. Fissure, longitudinal. Dua-dua, incomplete. Okay. Ni comminuted, shattered. Usually this one caused by a lot of stress ataupun tension, especially macam kena linyik kan, jatuh motor, tayar kena linyik dengan lori 18 roda, you're going to lose your hand. Hancur, mesti dia hancur punya ni. Dia payah nak sambung. So kalau kata the fracture is something like this, if the doctor able to reconnect everything and it's okay. If not, they're going to chop down. Wait. Jadi dia jadi lebih pendek sikit. Okay, dia akan buang yang shattered part. Okay, transverse fracture, we don't have the shattered, but we have a complete fracture between two piece of bone. Okay, and then this one, green stick, fissure, comminuted, transverse, oblique the diagonal. Most is caused by stress. This one, spiral, is caused by shear ataupun caused by tension. Means we have force from two different direction. Satu pusing kiri, satu pusing kanan. You are going to get spiral. Other than that, kamu akan dapat benda yang lain. It depends on the direction of the force we apply. Okay, ni contoh lagi satu. Okay, satu lagi yang tadi. The last fracture. Ni, avulsion. Avulsion ni macam ni. Kita akan dapat bone chipping. Okay, avulsion is when we have bone chipping. Mana gambar tengok bone chipping Oh, ni avulsion. Muka koyak. Okay, avulsion ni macam ni. This is your tendon. Okay, ini flexor. Okay, this is your flexor digitorum punya tendon. Bila dia kopak, it bring a piece or a chip from the bone or from the origin side. Ni origin. Okay, this is the origin side. This is the insertion side. So, origin side ni tempat tendon tu bercantum dengan bone. And when this fracture occurs, avulsion fracture, sekelumit tulang akan terkopak and it will attach to the tendon. Tu avulsion. Okay, dia tak patah but dia chipping. This one is chipping. Chipping caused by force being deliberately sent to the chipping site by the tendon. That is avulsion, caused by tensile loading in which a tendon or ligament pull a small chip. Sakit ni. Okay. So this is common injury towards skeletal. And then it depends on the site lah. Okay, kalau kata kita punya tulang panjang, long bone, quite common. Kalau kita kata short bone, this is not common. Comminuted, yes. Okay. Kalau kita kata tulang kita flat bone, most is going to be comminuted and also fissure. Macam terkorak kan, bila kita accident, it's going to have fissure. It is going to break, but not a complete break. Just an area of impact, you're going to get fissure. Same goes when it is towards your irregular. Kalau irregular, it depends. Like vertebra, it can get comminuted. It can get fissure. Like pelvic, most of the time it can get fissure, it can get avulsion. So it depends on the place. And based on the injury, some technique can be conducted in order to heal. Okay, in order to heal. Okay. When we talk about healing of this one, okay, kalau kata macam linear ni kan, not a complete displace. Macam ni, transverse complete, linear not complete, oblique non-displaced, there are still part will still attach. Oblique displaced means complete. For those complete, a bone remodel ke model yang akan terjadi dekat sini? What are going to happen here? Is it remodel or is it modeling? Yang mana yang akan terjadi? Modeling ke remodel? Modeling ke remodel?
Modeling.
Modeling will occur, which will result tulang kita ni dia akan ada parut. Sama macam bila kita luka kan, so kita akan ada kawasan yang jagged. Same goes as the bone. And throughout years, remodeling will occur in order to make the surface of the bone as similar as before. So first dia akan jadi modeling. They are going to make a new one in order to close all of this fracture. And then afterwards, remodeling will occur. Okay. So with that, this is the end of chapter 3, and next week we are going to continue with next topic, which is joint and cartilage. Okay, do you have any question for today?
No, sir.
Alright. Senang?
So far so good lah.
So far so good. Okay, so kita
Medium.
medium. Senang ni. Kita recap. Okay. Untuk bahagian tulang, there are several things you need to remember. One, appendicular dengan axial. Okay, satu. Yang kedua, name of the major bone. Yang ketiga, building block of the bone. Calcium carbonate, calcium phosphate, collagen, water, some sort of protein, and minerals. And then we have the type of the bone, cortical and trabecular. The differences is towards the sponginess, the rate of sponginess. All bone will have trabecular and cortical. Depend on the place, depend on the situation, the placement will be different. And then type of bone, we have 4. Long, where you have shaft, short, chunky and square, flat area, irregular bones, other than that. Okay. After that, we have Wolff law, we have bone modeling, bone remodeling. Okay. Make a new one, modeling. Change the previous to be better, remodel. Kalau lupa, rumah 10 bilik, kekal 10 bilik, bentuk berbeza, remodel. Rumah 10 bilik jadi 12, modeling. Okay. And towards the end, we have injuries, fracture, several type of fracture. So next week we are going to continue with joint and cartilages. Okay, if you don't have any question, just a reminder, don't forget to take your attendance in future, and this will be the 4th week. So you need to submit your journal review before the end of Friday. And I've checked, there are several of you still did not submit your integrity form. Please do so. Okay. Thank you again for your participation, and we are going to meet again next week at the same time, at the same day. Assalamualaikum and very good morning to everybody of you. Thank you. Good afternoon.
Thank you, sir. Assalamualaikum.
Waalaikumsalam. Thank you, sir.
Next week.
Thank you, sir.
Thank you, sir. Thank you, sir.
Alright, thank you.